We're going to continue working with that same example that we've seen in the last two videos, but this time we're going to talk about how we can use our graphing calculator to help us calculate the test statistic, which we were able to do by hand, but also to find an exact p-value, which we were not able to do by hand. So once again, just reading through the problem, the weights of diamonds are measured in carats. The difference between the size of a 0.99 carat diamond and a 1 carat diamond is undetectable to the naked eye. We would like to perform a hypothesis test to determine if the average price of a 1 carat diamond is higher than the average price of a 0.99 carat diamond. The information for each sample is given below. So a couple things that I want to mention before we begin. I have the null and alternative hypothesis that we set up in a couple of videos ago. If you need to look back at how we did that, take a look at the video for page 7.3.1. But we're going to need to know in particular what type of test we're doing. We said we were doing a right tail test. We said specifically mu sub 1 is greater than mu sub 0.99. So we've got our alternative hypothesis. We are going to need that information. And then the other thing that I'm just going to remind us of here is that we were calling the column on the right, the sample for the 1 carat diamonds, we were calling that group 1, and the sample on the left from the 0.99 carat diamonds, we were calling that sample 2. This matters a lot because when we enter our graphing, the data into our graphing calculator here in just a moment, it's not going to be able to determine the difference between sample 1 and 0.99. The graphing calculator always has mu sub 1 on the left and mu sub 2 on the right. And it's important that we correctly label which one is group 1 and which one is group 2 so that we're very clear. So we said in the last video, 53.43, that was our X bar 1, 12.22, that was our S sub 1, our sample standard deviation, and 35 is N1, 44.5 was our X bar 2, the sample mean for group 2, 13.32 was our S sub 2, and 31 was our N2. So it's helpful to have all this information laid out in front of us so that we can go and input this into our calculator, which we're going to do in just a moment right here. So we've got everything that we could possibly want out of this problem. The next step is to go tell it to the calculator. So hopping over to my graphing calculator, let's have a look. Oh, apologize for the ad. I need to start off by going into the correct hypothesis testing menu. So to do that, I'm going to press stats. I'm going to arrow over twice so that I'm under the tests menu. And I'm going to choose option number 4. It says 2 sample t-test because we have 2 independent samples. We're using our t-distribution. So we're going to go ahead and press enter. From here, we have a couple different options. For the input, it'll ask for either data or statistics. The data is if we were given the raw data. So if we had a list of price points for these 1 carat and 0.99 carat diamonds, and I didn't have like the sample mean and the sample standard deviation from each group, then I would have to, first of all, enter that information into L1 and L2, and the graphing calculator would pull that information and use that to calculate X bar 1, S sub 1, and so on and so forth. We already have that information though, so we don't have to mess around with that. We're just going to go to the right under stats, which is our summary statistics. And here's where we can enter in, here's our sample mean from group 1, our sample standard deviation, and so on and so forth. So scrolling down right here, I've got X bar 1 is 53.43, S sub 1, that is 12.22, and N1 is 35. Our X bar 2, we said that was 44.5. S sub 2 was 13.32, and N2, we said that was 31. From there, it's going to ask for the alternative hypothesis. So you'll notice that mu sub 1 is on the left-hand side, and then it says either not equal to mu sub 2, less than mu sub 2, or greater than mu sub 2. So we want to make sure we choose the correct alternative hypothesis. We said we were doing a right tail test, so we want greater than. Pooled, this part doesn't really matter. We're always going to leave this on no, and that's not an option you'll ever have to change for our class. So you can leave that on no. And then towards the bottom again, calculate or draw. Either option will give us the information that we need. If you click on draw, it will just give you an illustration of that p-value under the t distribution. So if you want to see that, you can look there. Calculate will give you a little bit more information, but both will give us exactly what we're looking for. I'm just going to go ahead and choose calculate here. So we are interested in the test statistic, which is t. So t is equal to 2.825, which is exactly what we said it was last time. And our p-value is right below it. It says p equals 0.003. So you'll notice, first of all, that we have an exact value for our p-value at 0.003. We can say exactly what that p-value is. But it also matches up to our prediction. Last time we said our p-value is going to be less than 0.005. 0.003 is certainly less than 0.005, but that's what I needed. That's what I need to in order to finish this problem. So hopping back over, we said that our test statistic, our test stat was t equal to 2.825, and our p-value here was equal to 0.003. So here I'm able to use my calculator to actually find that exact value of the p-value, which is really nice. The rest of this problem is going to look very familiar to what we've seen. We're just going to make our decision at the end of this problem and then interpret that decision. So I don't believe I actually stated an alpha in this problem. I said we'll just go ahead and assume alpha is the usual 0.05 right here. So again, I'm comparing that p-value to alpha. Is that p-value less than alpha? I'm comparing these two numbers. In this case, yes, the p-value is less than alpha, which means, yes, we will reject the null hypothesis. So our decision then is to reject H0. And then for step 3, interpreting our answer, that means that there is enough evidence to support the claim. So there is enough evidence to support that. And I'm going to just look at the claim that's being made here. What question were we asking? So we wanted to perform a hypothesis test to determine if the average price of a 1-carat diamond is higher than the average price of a 0.99-carat diamond. So there is enough evidence to support this claim. So there is enough evidence to support that the average price of a 1-carat diamond is higher than the average price of a 0.99-carat diamond. So the decision-making process and interpretation should feel the same as we've seen in all of our other hypothesis testing problems right here. I am going to ask you to give specific values for your p-values, so you will need to be familiar with how to use the graphing calculator, because you can't actually say exactly what the p-value is if you don't use the graphing calculator. So that is something that I'm going to ask you to do on quizzes and tests going forward. Last thing I want to talk about in this problem is actually just how to interpret it right here, because I think it is kind of interesting. So based on what we've said, in this interpretation for number 3, it says that there is evidence to support that the average price of a 1-carat diamond is higher than the average price of a 0.99-carat diamond. So based on our data that we have here, it appears that the 1-carat diamond costs more than the 0.99-carat diamond. But the other thing that we have here, it says the difference between the size of a 0.99-carat diamond and a 1-carat diamond is undetectable to the naked eye. So you can't tell just by looking at it the 1 carat diamond, that it's, you know, bigger than the 0.99 carat diamond, but it is going to be more expensive. So you would be able to make that decision, you know, how important is the weight? Is it important for you to know the weight even though you wouldn't be able to tell the difference? Or if you don't care about that, you could say, well, I'm going to save a little bit of money. I won't be able to tell the difference anyway, and it'll be a little bit cheaper to buy the 0.99 carat diamond. So I think that's just an interesting interpretation of the result here, and kind of an illustration of how we might use that hypothesis testing conclusion out there in the real world.